Let's just start right where you are. I want you to pay attention to your body, just for a moment. If you're sitting down, feel the pressure of the chair against your legs, against your back. If you're lying in bed, feel the mattress pressing up against your spine. It feels solid. It feels still. We call this weight. And if I asked you what was happening, you'd probably say, well, gravity is pulling me down, and the chair is stopping me. It sounds obvious. It feels like the most natural thing in the world. There's a force, gravity, reaching up from the center of the earth, grabbing you and pulling. And because the floor is in the way, you feel a squeeze. We live our whole lives with this sensation. We trust it. We trust that being heavy means being pulled. But let's slow down for a second. Because there is something slightly strange about this feeling, something that doesn't quite fit if you look at it too closely. Think about other times you feel a squeeze like this. Imagine you were in a car, a fast car. You're at a stoplight. The light turns green and the driver slams on the gas. What happens? You get pushed back into the seat. You feel heavy. You feel pressure against your back, just like you feel the chair right now. But in the car, you know why you feel that pressure. It's because the car is moving. It's accelerating forward, and your body wants to stay put. So the seat has to shove you forward to keep up. The heaviness in the car is proof that you are being pushed. It's proof that your speed is changing. Now come back to the room. You are sitting still. You aren't going anywhere. The walls aren't moving. The floor isn't moving. So why do you feel the same pressure? Why does standing still on Earth feel exactly like accelerating in a car? At first, you might dismiss this. You might say, well, gravity is a force. It's pulling me. That's the difference. But is it? Let's try a thought experiment. This is a classic one, but I want you to really try to live inside it. Don't just analyze it. Feel it. Imagine we take away the room. We take away the chair. We take away the floor. We take you up very high into the quiet air, and we just let go. Now you are falling. Ignore the wind for a moment. Imagine you are falling in a vacuum, or just falling very early before the air rushes past your ears. What happens to that heavy feeling? It's gone. The pressure on your back? Gone. The weight in your stomach? Gone. If you had a cup of coffee in your hand and you let it go while you were falling, it wouldn't fall to your feet. It would just hover right there next to you, because it's falling at the exact same rate you are. To you, looking at the cup, it would look like it was floating. And if you closed your eyes, how would you know you were falling? If there was no wind and no sound, you would feel completely weightless. You would feel exactly like an astronaut floating in deep space, far away from any planet. This is where it gets comfortable and a little uncomfortable, because we have a contradiction. When you are falling, when you are completely surrendered to gravity, you feel nothing. You feel no force. You feel no weight. But when you are standing still, when you are resisting gravity, that is when you feel the stress. So, here is the strange thought that physicists started to wrestle with about 100 years ago. What if our definition of moving is wrong? What if falling isn't really falling? What if falling is just coasting? Think about deep space again. If you turn off a rocket engine, the ship just glides. It coasts in a straight line. It takes no effort. It feels like nothing. When you jump off a diving board, for those 2 seconds before you hit the water, you are coasting. You are following the natural path that nature laid out for you. The Earth has curved the space around it, and you are just sliding along that curve. You aren't being pulled, you are just going where the universe guides you when nothing is in your way. That's why it feels weightless, because it's effortless. It is the natural state of things. But then, what is happening right now? What is happening as you sit in that chair? If falling is the natural, effortless motion, then sitting still must be the unnatural, forced motion. Look at the floor again. If you were falling, the floor wouldn't be there. You would be coasting along your natural path towards the center of the earth. But the floor is there. And what is it doing? It is interrupting you. It is getting in your way. In fact, it's doing more than that. It is slamming into you. To keep you from following that natural, weightless path, the floor has to constantly push you upward. It has to exert a force. Remember the car? The car accelerates forward, and the seat pushes into your back. The earth is doing the same thing. The ground is effectively accelerating upward, smashing into your feet every single second of every single day, keeping you from your natural path. I know, this sounds wrong. You look at the ground and it clearly isn't moving up. It's staying right there. But your eyes are judging motion by looking at the walls and the furniture. Your body, your inner ear, your stomach, the pressure on your skin is judging motion by forces. And your body is telling you something that your eyes refuse to believe. Your body is telling you, I am being accelerated. Your body feels exactly the same way it would feel if you were in a rocket ship in deep space and the engine was turned on, pushing the floor up against your feet. If you were in that rocket ship, far from Earth with no windows, and the engine accelerated you at a specific rate, you would feel heavy. You could stand on the floor of the rocket. You could drop a pen, and the floor would rush up to meet it, making it look like the pen fell. You wouldn't be able to tell the difference between the rocket ship and your living room. And that's the crack in the belief. That's the thing that feels so strange once you let it in. We tend to think that gravity is this active thing, grabbing us, pulling us down, and that the ground is just a passive stage where we stand. But it's actually the reverse. Gravity, the falling, is the passive part. That's just nature taking its course. That's just the geometry of the world. The weight you feel, that isn't gravity pulling on you, that is the floor pushing back. That sensation of heaviness you're feeling right now is the sensation of being knocked off your path. It's the sensation of the entire planet shoving you away from where you naturally want to go. So when you stand up, you aren't fighting gravity, you are being fought by the ground. It changes how you perceive the silence of a room. You sit there, it looks quiet, it looks static. But if you close your eyes and focus on that pressure on your skin, you realize you aren't static at all. You are being pushed constantly. You are in a vehicle that never stops accelerating, and the only reason you don't realize it is because everything else around you is rushing upward along with you. It's a strange image to hold in your head, isn't it? The idea that the ground is rushing up to you. And if you hold on to that image for more than a few seconds, a new problem starts to itch at the back of your mind, a very practical problem. You might be thinking, okay, if the floor is accelerating up, and the ground in Australia is accelerating up, and the ground in Africa is accelerating up, then the whole Earth must be inflating like a balloon. It must be getting bigger and bigger every second. Because if everything pushes out, the surface has to expand. But we know the Earth isn't getting bigger. it stays the exact same size. So now we're really stuck. We have this feeling, this absolute certainty from our bodies that the ground is accelerating. But we have this knowledge, this certainty from our eyes that the earth is staying still. How can both be true? How can a floor move upward constantly without ever actually going anywhere? This is where we have to stop thinking about forces and start thinking about shapes. Imagine you and I are standing on the equator. I'm a few hundred miles to your left and you're a few hundred miles to my right. We both decide to walk perfectly straight, due north. We are going to walk in a straight line until we hit the North Pole. At first, we are walking parallel to each other, like two lanes on a highway. The distance between us stays the same.